Hello, 7th grade. Got a new week of math again. We're going to go to 2 new lessons and going to get away from an old lesson and a new lesson. Also remember, so if we do have questions, make sure we always do the Zoom meeting Wednesday at 12:30 and Thursday at 2, just to answer any questions, or sit and chit chat and socialize just so we can know what each other are up to and all that good stuff. But we're going to get started. It's lesson 94, probability of dependent events, okay? And probability just means the chances of something happening. Dependent events, I'm going to give you the book's definition, and then I'll kind of try to provide an example. The book says an event is a dependent event if its probability is influenced by a prior event. Okay, so take for example, let's say I had a deck of cards, and I asked person A over here, I said, hey, what are the odds that I draw a king? Well, there's 4 kings out of 52, so the fraction would be 4 out of 52. Okay, let's say I don't replace it. Okay, I leave that card that I just drew, let's say it was a king, and I leave it out. Okay, I don't put it back in the deck. So that means in the deck I only have 3, and there's not 52 cards anymore. There's 51 cards. That's a dependent event, meaning the first part of the problem when I took out that king is now going to affect how the second probability for me finding another king. Okay, that's called a dependent event. And another example is example 1. Okay, so we're going to go ahead and we'll get started with that. It says 2 red marbles, 3 white marbles, and 4 blue marbles are in a bag. So I like to draw those out just so we can see, and I can have totals and stuff like that. So it says 2 reds, so I'm going to write 2 reds. I think it's 3 white marbles, and then there are 4 blue marbles. Yep, 4 blue marbles. Okay, so that leaves a total of 9. 9 is the total, just so we're aware of that, okay? And when you write probability, normally you just write it in fraction. That's usually how it's presented, more often than not, okay? Let's keep reading the question. And then it says, are in a bag. If 1 marble is drawn and not replaced, and the second marble is drawn, what is the probability that both marbles will be red? Okay, well, first off, we need to find out the probability that the first time it's going to be red. And it wants to know both, okay? So here's how we do that. We know there's 9 total, and we know there's 2 reds in it. So the first probability of us is going to be the fraction 2 out of 9, okay? So this is, I'll just write first draw, okay? And then that's going to be 2 out of 9. Why is it a 2 out of 9 chance? Because there are 2 reds out of 9 total marbles. Okay, so I have a 2 out of 9 chance of picking a red. Let's say I got it, and I have the red in my hand. I place it over here on the table. Now, there's no longer 9 total anymore. In fact, there's no longer 2 reds. Okay, there's only 1 red. And that actually means now there's only 8 left, or 8 total left in the bag. Okay, and then to figure out what is the probability that it happens, boom, boom, 2 times in a row, first draw and then the second draw, all right, second draw, okay? What you have to do is you have to multiply the 2 probabilities, okay? And in this case, there's 8 left in the marble bag. There's only 1 red left, so there's a 1/8 chance of getting that. 1 out of 8, okay? Now, when I said you multiply the 2 probabilities, this is the probability for the first draw, 2 out of 9. And this is the probability for the second draw, because there was only 1 red remaining, and then that left it to 8 total. So now if I do this and I multiply these, top times top, bottom times bottom, but first I'm going to simplify this so I don't have to do it at the end. Okay, I know 2 and 8, they have a common multiple, and that number is 2. So how many times does 2 go into 2? 1. How many times does 2 go into 8? 4. 1 times 1 is 1. And 9 times 4 is 36. Okay, so I'll get out of the way so you can kind of read all the work. But to answer the first question, here's what the question was. What is the probability that both marbles will be red? If I draw the first time and then I keep it, I do not replace it, I do not put it back in the bag, and then I draw another marble and that marble is also red. Okay, you figure out both the probabilities, which we did, and then you times them together. So for that to happen, in theory, it doesn't mean this is going to happen 1 out of 36 times. It could happen 3 out of 36 times. If you actually did an experiment, it could happen 5 times in a row. It just depends on the experiment. But in theory, it should only happen 1 time out of every 36 tries. Okay? That's what that means. So, I'll erase this one and we'll move on to example 2. Okay? Example 2 goes to a deck of cards. Okay, there's 52 cards in a deck, 4 suits, 13 cards of each suit. Those are stuff that are important to know when you're figuring out probability. Okay? It says 2 cards are drawn from a regular shuffled deck. What is the probability of drawing 2 aces? Okay, and they're saying in a row. And again, you do not put them back. Okay? So you draw 1 ace, you keep it, okay, and then you draw another one. So the very first one, there are 4 aces in the deck, and that's out of 52 cards. Okay? Now, we can actually simplify that. 4 goes into both of these numbers. Okay? So if I go 4 divided by 4, I'm going to get a new fraction of 1. Remember, this is my first draw to get an ace, okay? First draw. Okay, and we decided there's 4 aces out of 52 cards. I'm just simplifying the fraction. 4 goes into 4 1 time. How many times does 52 go into 4? If you divide it out, 13. Okay, so for the first draw to get an ace, in theory, you should draw an ace randomly 1 out of every 13 tries. Doesn't mean it's going to happen, but in theory, it should happen 1 out of every 13. Okay, so now I'm going to write that answer, 1 out of 13. Okay, that's our first draw. Now remember, we are going to multiply that by our second draw. We just have to figure out the probability, okay? So imagine there's 1 ace gone, okay? That means there's 3 left, and how many cards are left? Not 52, but 51. 3 aces left, not 52 cards in the deck anymore because we already picked the 1 ace. There's only 51 left. Okay, now you can reduce this as well, and actually 3 goes into both numbers. Okay, so if I do again, divided by 3, 3 divided by 3 is 1, okay, and 51 divided by 3, well, let's do it out real quick. How many times is 3 into 21? That's 7, okay? So, the second time of drawing that ace, in theory, it should happen 1 time out of every 17. So not great odds. Okay, now, to figure out what are the chances that I have a normal deck of cards, I pick a random card, it's an ace, I set it down on the table, and I pick another random card, and it's an ace. That's what we're figuring out. What are the chances of that? Okay, so now, when we do that, we need to multiply top times top. That's pretty simple. 1 times 1 is 1. Here's my final answer. I'll put it up here. Okay, 1 times 1 is 1. Now we need to do 13 times 17. 17 times 13. and I got 221. So the odds of you drawing 2 aces consecutively without replacing that card, in theory, is 1 out of every 221 times attempted. So it would be very, very difficult for someone to draw an ace, place it on the table, and then randomly draw another card that happens to be an ace. Okay, so again, what did we do? We figured out the probability of the first draw, which is 1 out of 13. We figured out the probability of the second draw, which is 1 out of 17. And then we multiplied those together to get the total probability of what should happen. Okay? That's all for the probability. If we have any questions, again, we will be on at Wednesday at 12:30 or Thursday at 2. So thank you and have a good day.